first for warm up, so let's look at these. Anyway, this is a review of homework. It's so weird, awkward. Anyway, okay. Okay, so on this one, again, first you always want to try to divide inside the radical. So if we simplify that, 42 divided by 6 is 7. X to the third over x gives us x squared. So first step, right? And then you just look and see what can come out of the radical. And actually this 2 should be up front. Okay, so 7, can anything come out of the radical? No, right? So it stays. But x squared, the square root of x squared is x, right? So it can come out. So we got that. Okay? All right, next one, multiplying. Again, they're both cube roots, so you can first multiply and you get 5 cube root of 27, x to the 5th, y to the 6th. Okay? And then, so now that's the first step, you've multiplied. Now you want to break it down. And we get 3 times 9, 3 times 3. And again, because we're looking for cubes, we need 3 of something. So 3 3s, so a 3 comes out. It's going to multiply with that 5. Everybody with me on this? 5 x's, so there's one group of 3, so 1x comes out. A 2 x's stay in. And then 6 y's, 2 y's come out. And none stay in. So it's kind of messy, but final answer is 15 xy squared cube root of x squared. Does everybody agree with that? Is that right? Okay. Okay. Next one, dividing. Again, this one's kind of weird because you can't simplify inside, right? There's no dividing that can really be done. But so now you look at the numerator and denominator. On the top, y to the third, what can we take out?
Y.
1y, right? And 1y stays in. Not 3. And then radical 3, we can't do anything with that either. So actually, it becomes that for now. This is what we're going to talk about in our notes in just a second. Okay? Questions about that? Okay, next one. We multiply it together. We get 100 x to the 5th. And then what comes out of that? 10. 10 and how many x's?
X squared minus 1.
Right. 10, so 10 comes out, square root of 100. 2 x's come out, and 1 x stays in.
I'm sorry.
Does that make sense?
Why does 1x stay in?
Okay, because it's 5, right? So, and we're looking for groups of 2. So there's one pair, there's another pair. So 2 come out, 1 stays in. Okay? Always think about doing, I mean, it seems pretty basic, but it really helps you, figure that out if you forget about it. Okay? All right, so what we're going to do first is finish last notes from last class, and it deals with this. So once upon a time, in a faraway land, mathematicians decided that you can't have a radical on the bottom of a fraction. That's the only explanation I know for it. I'm not sure why. But even like on the ACT, if you were to see this answer, you would not see this answer because there's a radical on the bottom. So there's a way to fix that, to clean it up. It's called rationalizing the denominator, and that's what we're going to look at. Okay, so I don't know any other reason why they wouldn't let a radical be on the bottom, except that they decided to torture algebra students. Okay, so to get rid of that radical on the bottom is called rationalizing the denominator. Okay. And again, it's just to simplify so that there are no radicals in the denominator. So the reason that it was on last class's notes, but I didn't keep it there because I think it just confuses the division process. So what I want you to think about it though is first do all the division, clean it up, simplify it, and then if you have a radical on the bottom, then do what we're going to learn today. Okay? So and the way to get rid of that radical is think about what's on the bottom. So it's radical 3 on the bottom. And we're going to multiply by that denominator. Okay? Because what is radical 3 times radical 3? radical 9, which is 3, okay? And that works no matter what, so you don't have to write this. But if I have like radical 2 times radical 2, it is radical 4, right, which is just 2. If I have radical 7 times radical 7, it's just 7. Anything, like if I had radical 111 times radical 111, it is just 111, okay? So we always just multiply by that radical, and it gets rid of it. So, radical 2 times radical 3 is what? It's radical 6. So radical 6 over 3, and that's all we can do on that, right? Because we cannot cancel the 6 and the 3, because this is not actually 6, right? It's radical 6. So you cannot cancel something inside the radical with something outside. Okay? So, radical 1, 7. Again, we've got, you can think about it, this one's a little tricky. You can think about it like this. Okay? And what is radical 1? 1, right? So you could even simplify it like this if you wanted to first. Okay? But then we have to get rid of that radical. So we do radical 7 over radical 7, and we get radical 7 over 7. And again, those cannot cancel because they're not the same 7s. Okay? Questions about that? But the other rules still apply. So if I look at radical 16 over 3, how can I simplify that first? Can I do that? Can I think about it like this? Can I do anything? Right, radical 16 is 4, so I can get it to be like this. And now, radical 3 times radical 3, I end up with 4 radical 3 over 3. Okay? Now, if I didn't think about that, 16, then I could have gone ahead and multiplied it by radical 3, and I would have gotten radical 48, and then I would have had to simplify radical 48 to get to here. Okay? So either way, it's just easier. The sooner you simplify, the better. Okay.
So after you simplify, you always have to use the bottom number to times it by.
Right, right.
Okay.
So the way to remember that is think about, the rule is we can't have this. This is what's causing the problems, right? So then you just multiply by that. Okay? Okay? Questions about that? All right. So let's look at this one. So this one I'm going to do a couple different ways. And this can get confusing, so, but I don't know how else to explain it. So there's a couple ways we can do this. First of all, I could look at this and think 9 over 6. Can I simplify just that fraction, 9/6? What will it be to you?
Like 3 and 2.
Right, so I could make it this. Okay? And so now it's as simplified as it can get, but I have a radical on the bottom, right? So I would multiply top and bottom by radical 2. And I end up with radical 6 over 2. Okay?
You just times on the cross.
When they're both under radical. Now, the other way I could have thought about this, I just want to show you all both because you'll end up with the same answer. But the other way to think about this is what could I do to this? Thinking about it as radical 9 over radical 6, what could I do? Make it 3 over radical 6, right? So that's fine too, but now to rationalize it, I do radical 6 over radical 6, and I end up with 3 radical 6 over 6. And now what could I do? Simplify it. Okay, so it's kind of a simplified before or after, either one. But always look at what you're left with and see what you can do. See if you can simplify it. Okay? All right, let's look at the next one. So it even works with variables. So again, if I think about this as radical 2 over radical 3x, so I can't do anything with the radical 2, right, or the radical 3x. So what do I do to clean it up? multiply by radical 3x, top and bottom. So 2 times 3x gives me 6x, right, over 3x. And again, I cannot simplify that because you can't simplify inside radical with outside radical.
So, will the answer always equal the bottom? Like, will the bottom always equal the radical on the bottom?
Yes, it should. Yeah. Actually, I'll show you one example where it wouldn't necessarily.
But if you show us?
Yes. Okay. All right. Let's look at this next one. So, what's one way we can clean this up first? Simplify how? The x's, right? We have 3 x's up top, 1 on the bottom. So first we can make it x squared 5y, right? What else could we do? Right, square root of x squared is just x, so we could get it down to here. So now it's as simplified as it can be, but we have to rationalize the denominator, right? So we multiply top and bottom by radical 5y. So our answer is x radical 5y over 5y. Okay? Questions about that? Okay, I want to show you one more example because it's on this worksheet we're going to look at in a second. And let's say we had let's do this. Okay, so radical 1a. Okay. Okay, so we can't do any division, right? We can't simplify 1 over 8, but we can think about it like this. And how does that simplify? What's radical 1? 1. And what's radical 8? 2 radical 2. Okay? So this, Caroline, is the only time where you might not end up to be your exact denominator. Because what bothers us about this? Does the 2 bother us? I mean, probably nothing bothers you all, but the math gods don't like that. This 2 is okay, right? But it's the radical 2 that we can't have, right? So we can just multiply by radical 2. And we get radical 2 on top. Now what's that? Yes, exactly, 4. Good job. Okay, everybody good with that? What that becomes is radical 2 times radical 2 becomes a 2, and 2 times 2 becomes a 4. Okay, so that's the only, and you could have, again, we could have back here multiplied by radical 8 and simplified later, and that would have been okay. Okay, but either way. All right, okay. So we're going to work on our worksheet. Okay, all right, so that was rationalizing denominators. Now we're into 6.3, which is technically called binomial radical expressions. But it's really just adding and subtracting radicals, okay? And the main thing you want to think about when we're adding and subtracting radicals is you want to think about it like that, like just combining like terms, okay? For instance, if we have 2x plus 3x, what's that equal? Not a trick question. 5x, right? 2x plus 3x gives us 5x's. What about 2x plus 3y? Nope. Right, 2x was, you cannot combine those, right? You can multiply, if it was 2x times 3y, it'd be 6xy, but you can't combine them, okay? Radicals are the same way. If you think the radicals don't represent a variable, but you want to think about them like that. Because, God bless you, you cannot, the radicals have to have the same index, and the same radicand, which that means the number under the radical. And then you can combine them. Sometimes you have to simplify the radicals first, but then you end up just combining radicals. Okay? So, for instance, okay. So, for instance, the way I want you to think about these, like for this first one, I want you to think 2 radical 3's plus 4 radical 3's give you how many radical 3's? 6. Okay? And that's something, it's not really natural to think it like that, but that's what you want to, that's what I want going through your head, okay? Because the radical itself stays the same. You're just collecting radical 3's, okay? Yeah. Yeah, okay, thank you. Okay? Next one. And it even works with variables under the radical. So 10 radical xy's minus 6 radical xy's give us how many radical xy's? 4, right? Okay? Questions about that? Okay, now it's not always that simple, because sometimes even though you couldn't simplify them at first, you can if you simplify. So 5 radical 3, it's fine, it's as simple as you can get. Radical 27, the way it's written right here, I could not combine them, right? But this is not in its simplest form. So if I come over to radical 27, it's 9 and 3, 3 and 3, right? So I've got a pair of 3's. So radical 27 becomes 3 radical 3's. Okay.
Why to define a pair of, oh, never mind.
Good? Okay. So 5 radical 3 plus 3 radical 3 gives us 8 radical 3. So the key here is not necessarily to try to make them match, but it's always to get them all down to simplest form and then see what combines, okay? 2 radical 5 minus 8 radical 17. So right now they won't combine. And even if I tried, there's nothing that can combine with, right? Or nothing that can't simplify. So it's not a no solution. It's just like whoever answered this question. Was it Taylor, I think, or Sam? So 2x plus 3y just equals 2x plus 3y, right? You just can't get any simpler. So on here, you could leave it like that, or you could say cannot combine. Either way is okay. It's not no solution. Okay. This next one is just a duplicate. So 10xy minus 6xy is 4xy. Okay. Now 5 radical 12x plus radical 3x. Again, the way it's written, we can't do anything with it, right? But this is not in simplest form. So what can we do? We can't do anything with the 12, but what can we do with that? I mean, we can't do anything with the x, so what can we do with the 12? Right. This is 4 and 3. So this becomes 2 radical 3. Right, so the 2 and the 5 multiply together. So we get 10 radical 3x. Does that make sense? Plus, this is a 1 radical 3x. So I end up with 11 radical 3x. Okay? Questions about that? Okay, they get a little more complicated. Go ahead and try these next 2. So the way I want you to do these is I want you to simplify this completely, then simplify this completely, see if they match, see if you can do it. And same on the other 2. Okay. Okay, so 18y squared simplifies to what?
3y radical 2.
3y radical 2. Does everybody agree with that? right? Because 18 was 9 times 2, so 3 came out. All right, and then 50 simplifies to what? Right, 5y radical 2. So the radicals are the same, so we can combine them, right? And can we add 3y plus 5y? Yeah, right? So it becomes 8y radical 2. Okay, does that make sense? Now the next one's kind of tricky. So how can we simplify x to the third? What can come out of x to the, if we have 3 x's, we have a pair, right? So 1 can come out. So it makes it what outside, Liz? X squared, right? So x squared radical x. And then same thing over here, right? And x can come out. So it becomes negative 2x squared radical x. So x squared, so think about this as 1x squared minus 2x squared gives us, Taylor? Right, negative x squared radical x. Now, if you, the other way you could have done this is because the radicals did match already, right? You could have done x minus 2x gives you negative x, radical x to the third, right? And then simplified it. And you would have brought an x out, and you would have gotten the same answer. Okay, does that make sense? Okay, so now, okay, so now I want you to do the other side. Okay, all right, so let's go over a couple of these. I know some of you are still working, but let's look at, actually, let's just look at the, well, we'll look at number 8. So 3 radical 50 minus 4 radical 72 plus 3 radical 8, right? So again, don't worry about trying to make a match right away, just simplify them. So 50 is 25 and 2. So radical 25 is 5, so we get 15 radical 2 minus 72 is 9 and 8. So, or no, 72 is not 9 and 8. It is 36 and 2. So a 6 comes out, multiplies with that 4, so negative 24 radical 2. And then 8 is 4 and 2. Oh, let's see. So that becomes 6 radical 2. Okay, so then you get 15 minus 24 plus 6 gives you what? Negative 3? Yeah. Okay, does that make sense? Now that last one, I won't go through all of that last one, but the last one doesn't combine all the way. But you end up with 10 radical 3 plus 5 radical 5 minus 9 radical 3 plus 12 radical 5. Okay, so again, it doesn't get all down to one term, but you can combine the 5, so you get 17 radical 5 plus 1 radical 3. Okay? Questions about that? Everybody okay on these? Okay, we are going to go through one more thing of notes. So log back on. We're just going to do this one last one. Or it's not the last one, though. It's actually pretty simple. It's spoiling, so it's loads of fun.
Wait, are we doing the last page?
Just this page. So multiply binomial radical expression. Okay, am I on this one? Okay, so the good thing about this is now that we know how to multiply and now that we know how to add, subtract, we know how to FOIL. Okay, because it's just putting those together. So all the rules still apply about multiplying radicals, etc. And now we can apply it to FOIL. So yay. Okay, so remember, FOIL is first, outer, inner, last. So first, 4 times 5 is 20. Outer, 4 times 4 radical 2 is what? 16. Okay, does everybody agree with that? Okay, so 16 radical 2. Okay, and then inner is 2 radical 2 times 5, so that becomes 10 radical 2. Oh. And then last, this is the tricky part. Last, we have 4 radical 2. I mean, I'm sorry, we have 2 radical 2 times 4 radical 2. Now, no shout outs on this one. So again, remember multiplying. The outsides multiply, so 2 times 4 is 8. And now radical 2 times radical 2 is what? 2. So we get 16. Okay, that's the hardest part
There's
about it.
also radical 4 and then that goes.
Right, or you could think about it as 8 radical 4, which is 8 times 2, which is 16. Okay? So now we get plus 16. So now, we look at what can combine. So Caroline, what can combine?
16 radical 2 plus 2.
Right, the radical 2's combined to get, so we get 26 radical 2 combining the radical 2's, right? And 20 plus 16 becomes 36. Okay, questions about that? Ava, you good? Okay. So let's try the next. So they're easier when you don't have that, the combos, I guess you might call them. So if we try this one, 3 times 5 is 15, right? Outer 3 times radical 7 is just 3 radical 7. Inner, negative 7 times 5 is negative 5 radical 7. And then what's negative radical 7 times positive radical 7 is just, Kayla, what do you get?
Negative radical 7.
Well, negative 7.
7.
Correct. That make sense? So now 15 minus 7 is 8. 3 radical 7 minus 5 radical 7 gives you negative 2 radical 7. So you guys try the next one. Okay, so,
I'm scared how I'm
okay, so if we look at 3 times 2 is 6. Go through that. 3 times 4 radical 5 is 12 radical 5. Inner is 4 radical 5. And remember, 2 times 4 is 8. Radical 5 times radical 5 is 5. So this becomes a 40. Okay? Then combine 6 times 40, 6 plus 40 is 46. 12 radical 5 plus 4 radical 5 is 16 radical 5. Okay? Now I'll do this last one together real quick, so I don't have time. So negative 3 times 2 is negative 6. Negative 3 times negative 2 radical 10 is positive 6 radical 10. Negative radical 10 times 2 is negative 2 radical 10. Now negative radical 10 times negative 2 radical 10 is negative 1 times negative 2 is positive 2, right? And then radical 10 times radical 10 is 10. So that becomes a 20. Does that make sense? Do you all get that? So it becomes 14 plus 4 radical 10. Okay? Now everybody stay logged on.